This video is going to briefly go over how to produce information about transition to crown and spotting in Behave7. We'll start with a new worksheet, use the guided workflow, and select surface and crown. For outputs, I am interested in fire behavior, rate of spread and flame length. I'm interested in crown information. And I'm not interested in size. I'm interested in spot, torching trees. I do not anticipate having crowning problems on my prescribed burn. If you were doing wildfire model, you might choose that one. My fuel model is going to be a TU5, which is where I have the highest potential for getting up into the trees. I will use the fuel moisture option. And at this point, I can decide whether I want to know at what point in my prescription I'm going to get torching, or I can choose to vary my canopy heights. We'll do moisture scenario first. So in my range selector, I'm going to do 15 to 5 in steps of -2. This just changes the way that the table is structured and viewed at the end. Insert my range, go with a 7 and an 8, and a live woody moisture of 90. Winds are at 20 feet, and I'll do a range of winds as well. Go from 5 to 25 in steps of 5. Insert range. Wind adjustment factor based on my fuel model is a 0.4. It's just a more dense canopy, slows the wind down a little bit. My wind and slope are aligned, and I've got a slope of 15%. I'll be using the Finney method. My foliar moisture I will use as 100. Canopy height is around 75 feet. My canopy base height, this includes the brush. So the canopy base height, including my brush, is probably 2 feet. My bulk density I'll put at 0.15. These are values that you can get from observations for some of them, or land fire data could give you your canopy bulk density. Downwind, the canopy is closed. Downwind canopy height is also 75. The number of torching trees inside I'll put at 2. These values might switch around as this versions get updated. Diameter we'll put at 12. Torching tree species we'll put at Douglas fir. Torching tree height, 75 feet. Actually, the shorter ones would torch. I'm going to go ahead and put 50 feet for that. My ridge to valley elevation difference is 300 feet. This burn that I'm planning is on a ridge top, and the valley distance is 3/4 of a mile. Check my inputs. Got them all. Not having any shading. And let's look at my output tables. It looks like under wet and low winds, I'm still getting torching, and that is probably because of those low canopy base heights. So what that tells me is I need to make an adjustment to my canopy base heights, maybe with some fill treatment. So I'm going to go back to my inputs and look at my fuel moisture. Instead of doing a range of fuel moistures here, I'm going to make them just one fuel moisture. And I'll try my lower end. Close that range selector. And now I'll go to my canopy fuels, and I'm going to make a range of canopy base heights. So it goes from 2 to 10 in steps of 2. And I'll process that. So what I can see now is that looks like under a canopy base height of 10 feet with low 20-foot winds, I'm not getting torching. This is one of the challenges with the TU5 fuel model, is, at least for my area, it over predicts that fire behavior. So I'm actually going to make another adjustment. This right now, it's not matching with my experience. It's important to pair your experience and use this modeling program to support your own experience. It's not meant to give you answers blindly, and it's not also meant to be ignored. It can be a support. So I'm noticing this TU5 is not representing the fire behavior that I have experienced in this area. I know I also have TU2. I'm going to see how this changes when I model it with TU2. So everything else is going to stay the same. And under the timber understory fuel model, I have quite different torching behavior. So with a canopy base height of 4 and 5 mile an hour, 20-foot winds. So based on what I'm seeing here, 15-foot, 20-foot winds and below are more likely to lead to surface fire. If we have lower canopy base heights or higher shrubs and higher winds, we are likely to get torching. When we get torching, what occurs? So you can see that these rates of spread and flame length, these are for the canopy, fire spreading in the canopy, flame lengths specifically. When it breaks into canopy, then these are all surface fire flame lengths. When it moves into canopy, those are the canopy fire flame lengths. And max spotting distance from these are 0.1 miles to 0.3 miles. And that's helpful for anticipating where those spots could go. With this information, you can adjust your prescriptions. You could also adjust your fuels so that you can decrease the likelihood that you will get fire moving from the surface to the canopy. I encourage you to play around with different inputs so that you can see which of those factors is driving the outputs that you're getting.